Hello and welcome to Beyond Thinking, where we share and discuss about space exploration and humankind. Join us and keep watching. But first, if you like this content, consider liking and subscribing to hear more about Beyond Thinking. Today's video is about an unusual planet that's entirely covered in water. This rare, twice the size of Earth planet has been found by astronomers, and it may have an ocean all around it. The abbreviation for TOI 733b for this planet is TESS Object of Interest 733b. TESS is an acronym for Transiting Exoplanet Survey Satellite. In an astonishingly quick 4.9 days, it completes an orbit around a star that is only slightly smaller than the Sun. That is strange because the planet's orbital period suggests that it is too close to the star. This indicates that something remarkable is taking place on the planet for it to be able to support an ocean of water on its surface. Consequently, the long-standing exoplanet mystery of the Radius Valley puzzle has been solved with the discovery of this exoplanet. The exoplanet discovery. How are astronomers able to locate this far-off planet? What indicators point to the potential presence of water on the ocean surface? Last but not least, the importance of this exoplanet's discovery to astronomy cannot be overstated. The universe has been relentlessly explored ever since the first exoplanets were discovered in the 1990s. Exoplanets have been discovered in an astounding range of types, from small rocky worlds like Earth to enormous gas giants like hot Jupiters. Terrestrial planets normally have radiuses half that of Earth, whereas gas giants can have radii of up to 10 times that of Earth. These planets demonstrate a wide range of radii. But there's a glaring gap between these groups. Exoplanets with radii between 1.5 to 2 times that of Earth are unexpectedly few, leading to the so-called Small Planet Radius Valley. The Radius Valley. Its origin is still unknown, but it divides two groups of planets, typically referred to as super-Earths and mini-Neptunes by a Radius Valley. According to one theory, super-Earths are the result of the mini-Neptune atmospheres being stripped away by photoevaporation or core-powered mass loss, leaving only the Earth's atmosphere. Also known as the Fulton Gap, the Photoevaporation Valley, or the Sub-Neptune Desert, this is the region where planets are thought to be scarce. The theory. Different explanations have been proposed by scientists to account for the scarcity. One theory proposes that mini-Neptunes, which are bigger than super-Earths but smaller than gas giants, slowly contract over time to become terrestrial planets with sizes comparable to Earth. The method by which this downsizing takes place, nevertheless, is yet unclear. As it gives a potential key to solving the puzzle, this is where the finding of TOI 733b becomes extremely significant. TOI 733b planet. An exoplanet called TOI 733b is located in the southern celestial hemisphere, about 245 light-years from Earth. After the first exoplanet was found in the 1990s, we now know about more than 5,000 others. It revolves around TOI 733, a yellow star with nearly 96% of the solar mass. The TESS results were the first used to find the planet. Since it is the 733rd TESS object of interest, the name denotes that fact. TESS searches for exoplanets using the transit method. The brilliance of the host star briefly decreases as a planet passes in front of it. It is possible to determine whether a planet is there by examining these variations in the starlight. To date, the transit method has been used to confirm the vast majority of exoplanet discoveries. The transit method. Some of the planet's critical physical properties can also be revealed using this technique. For instance, one can determine the planet's orbital period by looking at the time when the starlight is dipping. With an orbital period of 4.9 days, it travels in a fairly tight orbit to its star. High-intensity photons from the star can ionize the planetary atmosphere at such a close distance and finally scatter it away. Many Neptunes may contract by a process known as photoevaporation, which is a phenomenon. The amount of sunlight obscured by the transiting exoplanet was used to determine the radius of TOI 733b. It falls within the Valley of Tiny Planet Radii since it was estimated to be 1.99 Earth radii. The planet's mass was calculated as the next stage. In order to look for exoplanets, it monitors the radial velocity of the star. To do this, astronomers employed the HARP spectrograph. The ESO's 3.6-meter telescope in Chile is equipped with the high-precision spectrograph known as HARPs. HARPs, the process. The star moves in a tiny circle or an ellipse as a result of a gravitational interaction between the planet and its star. The star's light spectrum is affected by this movement, which is visible from a distance. The spectrum of a star traveling in the direction of the observer seems slightly blue-shifted, whereas the spectrum of a star moving away from the observer appears red-shifted. The strength of the gravitational attraction between the two celestial objects, as well as the planet's mass, are revealed by the spectrum analysis. The identical observations for the star allowed the planetary mass of TOI 733b to be fixed at 5.72 Earth masses. The information available thus far, such as the planetary mass and radius, enables the determination of the planet's density. The data point to a density of 3.98 grams per cubic centimeter, which is slightly lower than that of Earth, or 5.51 grams per centimeter cube, and slightly greater than that of Mars. This is when things start to get interesting. Mostly based on its density, the discovery has opened the door for some intriguing theories regarding the planet's composition. The hypothesis. According to one theory, the exoplanet may have once had a hydrogen-helium atmosphere akin to Neptune's. If so, photoevaporation may have gradually taken away its primordial atmosphere. However, it's possible that this process resulted in the reconstruction of a secondary atmosphere that was predominantly made up of heavier elements. Alternately, and this is the most likely scenario, the planet is an ocean world. Even in this case, photoevaporation would have caused the exoplanet to lose its original atmosphere of hydrogen and helium. The twist is the potential for a water vapor-rich remnant atmosphere, which is far more resistant to photoevaporation. According to this scenario, the planet has most likely preserved a sizable portion of its atmospheric mass, creating an ocean world. The biggest challenge is still figuring out whether TOI 733b is an ocean planet or has a secondary atmosphere. Method of analysis. For a conclusive answer, a thorough examination of the atmosphere of the planet is necessary. A comparison of starlight that has been filtered by the planet's atmosphere with unfiltered starlight is currently the most accurate technique for such a study. The next generation of telescopes is awaited before learning more about TOI 733b's atmospheric secrets because it is not the best choice for such a probing operation. The answers to this valley's puzzles may lie on exoplanets like TOI 733b that are found within its radius valley. Particularly, this exoplanet is a fantastic subject for such investigations. It encapsulates a minor yet potentially significant element of the extraterrestrial science puzzle. Therefore, subsequent follow-up observations and studies will surely yield worth scrutinizing data. TOI 733 study of I. Georgieva et al. 2023. Their research focused on the identification and characterization of TOI 733b, a planet found by TESS and located in the Valley of Tiny Planets. They have demonstrated that its potential makeup makes it a very fascinating and significant planet that can be used to demonstrate the existence of water worlds near sun-like stars. space-based light curve photometry from TESS, follow-up ground-based photometry from Las Cumbres Observatory Global Telescope, or LCOGT, speckle imaging from the Zorro instrument at the 8M Gemini South Telescope, and spectroscopy by the HARP spectrograph at the 3.6-meter telescope at La Silla Observatory were the instruments used to confirm the planetary nature of TOI 733.01b. On the mass radius diagram, the planet's moderate density places it in the zone between rocky and volatile-rich planets with the HHE-dominated envelopes. They constructed planet interior and atmosphere models by combining these with star parameters and abundances. This suggests that TOI 733b has a volatile-enriched, most likely secondary outer envelope and may be a heavily irradiated ocean world. This is one of the few well-characterized planets of this sort that orbit G-type stars. Any attempts to examine the aforementioned planet in an effort to understand more about its atmosphere will, however, have to wait until the next generation of telescopes. If you have any thoughts on the ideas discussed in this video, please leave a comment below. If you enjoyed this content and would like to see more on space exploration and humankind, please like this video and subscribe for more videos on Beyond Thinking. Thank you and have a Beyonder night.